Good morning, ladies and gentlemen, colleagues and friends. I'm Peter Doyle, very happy to have you here after the gala dinner and dancing of yesterday evening. We have an exciting session ahead of us on value chains and innovation. We have here a superb panel, a biologist, a chemist, a zoologist, and a physicist. I will introduce you the panel briefly, and then we will hear their presentations and enter into a family discussion, given the circle we have this morning here. It worked very well yesterday and the day before with Slido. Perhaps today we can even do it more directly, but you can use Slido, just hashtag name of conference and the room number A. But I would be more than happy to take questions in a very direct and spontaneous way. So let me start in this order, and I'll start with Didier Jans. Didier is the Director General of the Industrial Minerals Association. He deals with all kinds of fantastic minerals. And myself being a stupid lawyer, I will not go into details of kaolin or diatomides, but Didier knows all about it. Didier is the biologist in our panel, and he started his career in the industrial mineral sector. He took care of the food and feed chain, and now as Director General for the Industrial Minerals Association. He has extensive experience in EU regulatory and decision-making process, so one of the shakers and movers in Brussels. Next to him is Suzanne van Berken. She is the physical and a bit of chemist in our panel here. She holds a PhD and works at Utrecht University. She works now for Unica Technologies, and there she is responsible for research and development regarding PET depolymerization. And she is also particularly knowledgeable in the field of upscaling, a recurrent topic in our conference. Next to her is Paul Leonard. He started with Dow Chemicals and then moved to American Cyanamide. So he has experience US, Middle East and Africa. And 16 years ago he joined BASF, a little company in Germany. And there he's in charge of government relations and for corporate innovation and technology. He was for years board member of the British Chamber of Commerce in Brussels. And I can tell you, they know what they talk about, very influential. If you're invited there, you have made it. So that is Paul Leonard. And last, certainly not least, Anne Goldberg. I know Anne for quite some years now. She is the lady for innovation. She is our physicist in the panel from the Université Libre de Bruxelles. She works for a couple of years for Solvay, and she has a job title which makes me, or a mandate which makes me really jealous, because she is in charge of finding, scouting breakthrough technologies. And she's also in charge of the new innovation platform. She's the director, and identifying the new breakthrough innovation. So I think I'm very proud of this panel. I'm very grateful that you made it here to our fantastic conference, so well hosted by the Slovak presidency. This, as a word of introduction, I think we will have some complementary, perhaps also hopefully some controversial statements, so that we have a good discussion and increase our level of knowledge. I give the floor to you, Didier, first, please.
Thank you very much, Peter. Thank you for this nice introduction. Good morning, everybody. Thank you for this early wake-up. IMA Europe, so I'm working for IMA Europe, Industrial Minerals Association. So we are indeed representing this whole range of minerals which are non-energy mineral, we don't speak about petrol, and which are non-metallic mineral, we don't speak about iron, copper and this kind of things, but we speak indeed about this kind of minerals like talc, kaolin, feldspar, silica, this kind of minerals which are used in a wide number of industrial use. To give you a few examples of these uses, well, glass, as you know, is made of silica, so there our material represents 100% of the material there. We are in the paint, for instance. Paint contains something of the order of 50% of minerals. Ceramics, that's 100% minerals, which is cooked. Paper, a sheet of paper, this nice sheet of paper is about 50% of all minerals, and so on and so forth. Many, many more applications, being usual application, but also old tech applications. I just wanted to take one example, a car. Well, in a car there is plastics. When you look at the plastic in a car, you have about 50% of the plastic inside the car, about 14% under the hood, and about 30% on the outside of the car. All these plastics and polymers, whether you speak about the seatings, you speak about the instrument panel, if you speak about the lighting glasses and so on, all these plastics contains minerals, contains different type of minerals which grant the physical and chemical properties of these plastics and polymers. So if you look, and clearly there is an evolution, and that's part of the innovation, there is an evolution in the amount and nature of these minerals in the plastic. If you look at, taking the example of talc, for instance, if you compare a car in the years 2006, it used to contain on average a bit less than 5 kilos of talc on the entire car. Today, well, at least in 2014, a car was containing about 13 kilos of talc, and that's going on. Talc is only an example, but there are many others. There is kaolin, there is calcium carbonate, there is diatomite, mica, and so on and so forth. So just one example. We don't see them, but they are there, and all this stuff would not exist without the minerals in their composition or in their manufacture. It goes to other examples. This one that we can live without anymore is full of industrial minerals in different parts of it. You can speak about the metal part, which is cast and needs the industrial minerals to be cast and to be formed. You can think about the glass, which is silica, but which is also polished with abrasive, which are industrial minerals. You can see about the plastic on the back, which is containing carbon, which is containing talc and other things in the plastic to reinforce, and so on and so forth. So this stuff are definitely relying on all minerals as well. So it's not only, you know, the niobium and this kind of thing which make the big titles. There are many other minerals that are the basis of all manufacturing industry, and basically everything that surrounds us. You can look around you here, there is nothing, in fact, that does not contain industrial minerals or where industrial minerals have been critical in the process and the manufacturing. That was not foreseen, sorry. We have actually our industry is based on three pillars. The first, of course, is the mineral, is the ore. So we rely on what is in the earth. So we need to find that out, we need to extract, we need to produce. That's, of course, a big part of it. If you don't have the right ore, of course, the mineral won't be produced. That's the obvious basis of it. What is very, very important after that is that we are not only selling stones, but we are also selling technology. So there is a big part of our work, of our industry, which consists in evaluating these minerals. We need to sort them out, we need to grind, we need to coat, we need to treat. So basically, the initial ore is just one part of the story. The processing and the high level of technical skills which are associated to it is very important for giving to the minerals their necessary properties. And then the third point, and which probably is very different from from a number of other products is the direct relationship with the market and with the end user. That's a characteristic of our sector. We are not a commodity business, so you won't find calcium carbonate and so on the stock market that you can buy anywhere. You need to buy that from a specialized company, and in general, no, in all cases, in fact, the supplier and the user are in close contact and very often in close technical discussion and contact in order to get the product they need. So definitely a specialty business, not a commodity business, and it's increasingly so that it's developing. Very important aspect as far as our discussion of today is concerned on innovation and where we are going. That's a very important dimension, this fact that we are integrated in the value chain and there is a very strong dialogue of the need and possibilities of what the user needs, but also what we can provide. Well, this conference is about the need for reindustrialization. I'm not going to the details. A number of much more competent people have touched to that over the conference. Clearly, I think one of the line we can draw is that our industry is not on the path of the 20% reindustrialization that has been claimed and which is looked for. Clearly not. We can discuss a bit about the exact figure, the way you take them, whether you take them in constant prices or not, but basically there is a clear decline of the industrialization of Europe. It's not true for everything. When you look at the table on the right, well, the manufacturing industry is clearly declining. You have other activities which are rather on the growing slope, whether you speak about finance and public administration and things like this. There is very interesting analysis in the last competitiveness report that has been published by the European Commission. The last one dates from 2014, which tend to conclude that maybe the damage is not that strong as what could read and could appreciate at the first sight. I think we have to take that with quite some caution. It shows that it's not a no hope, but certainly it also shows that the kind of damage limitation that we know is partly limited, is largely due to very few sectors. It's due to export and it's due to the growth in other regions of the world. So I don't think we should draw too hasty conclusion on the wealth of the manufacturing industry in Europe. It's really in a critical state today. I wanted to give you a few examples because I told you there is a close relationship between our industry and the downstream market, and I just wanted to show you that indeed innovation is on its way, and it's on its way to maintain the competitiveness of our industry, not only of our mineral industry, but also the competitiveness of our user industries. I've taken here some examples, an example in cosmetic, water, and so on. I'll scroll quickly through these different examples. The first one I wanted to share with you is a development by one of our company, which is called Immercare. The issue there was the fact that the oil-derived microbeads, which are used in wash-off cosmetics, needs to be revised. So these microbeads actually are very small pieces of plastic which are included in many of the cosmetics. And one of the problems with that is that it's creating, well, an obvious environmental issue. These microbeads does not dissolve, does not degrade, and they are spreading all over the place, all over the water and then the oceans, and they get through the water treatment processes. So the target here of the development between our companies and the cosmetic company was to find an environmental friendly alternative to these microbeads. And indeed, a product has been developed. This product is based on perlite, so a volcanic earth, and together with the company and the cosmetics company, the specific properties of this perlite have been tailored to the needs of the cosmetic industry. That's where I was talking to you about the importance of the technological skills and processing of the particle and of the material. That's clearly what happens here. It's not only that you take a rock in the earth and you can use it like this. There is a lot of technology, grinding. Here it's a matter of expansion and heating and things like this. So the design of the particles fits exactly what the market needs. At the end of the day, the target was met, and these products start to replace the plastic microbeads in the cosmetic industry. Another example, wastewater treatment. Here we speak about the removal of particles, so the liquid-solid particle separation. Here again, there was at the basis an environmental concern. So the idea was to replace the conventional polymer or aluminum-based flocculant which are used there, which also have a relatively difficult environmental profile, and to find an alternative to that. Here, the alternative was found through calcium carbonate, and again, it was designed in the format, in the form and in the specifications of the calcium carbonate that was designed for that. The advantage here, they play with the surface charge of the particles. The advantage is that it allows a very tailored supply of material according to what the user needs. And in fact, this has evolved not only in a product development, but in a real service development. So the supplying companies today are not only selling calcium carbonate, but they are really in partnership with the water treatment companies and tailor the product to the exact need. They make the analysis and so on and so forth. So it's a real service dimension here. So we are here with an innovation which is both a product innovation, but also a kind of organizational innovation type. Other example, we are in the plastic, in the polymer world here. Here, the issue was to increase the thermal conductivity of a polyamide while maintaining its technical and its physical properties. So it's a piece of it's a fan which is used in car engines. So here, the need was to design and to design a mineral, a filler that would allow this characteristic of the plastic. This has been done. One of the difficulty was, of course, while replacing the plastic and the polymer by the mineral to keep the properties, to avoid cracking, to get this thermal conductivity. Again, through this dialogue and cooperation between the mineral supplier and the user, they have reached the characteristic of the polyamide that they need, and they've improved the performance of this type of fans. It goes also to very intimate aspects. I'm sure the next example, many of us have that in our minds for the time being. So we speak here about the fillers for the teeth. Here the idea is to increase the mechanical properties and the shade adjustment aspect of artificial teeth and amalgams. You know that in most of the case the amalgams have been replaced by polymers with the minerals. There was here also a demand and a cooperation between the supplier and the user. The answer was provided by highly pure and superfine feldspar that have been specifically designed and manufactured for this kind of application. Again, the expectation of the customer were met in terms of the characteristic of the product and the final performance of the alternative to the amalgam. Well, another example in electronic here. Here we are in epoxy resins. These epoxy resins are used to laminate circuit boards and things like this. Here again, the idea was to tailor and to ameliorate the epoxy resins which are used. Again, a very high-tech dialogue and research program between the supplier of the product and the user. In this case, it's a silica floor that was used and designed for this kind of application. I told you that we are in the paint as well. There is a tendency to have high gloss indoor paints. These paints are largely based on, again, polymers and pigments and things like this. And there is, of course, an interest to add filler to this paint. One of the difficulties is that in general when you add filler to the paint, you reduce the gloss of the paint, and here the exercise was to maintain the gloss of the paint while increasing the filler load. That was done again by designing and tailoring the characteristic of the filler. Here it's a calcium carbonate, a new type of calcium carbonate that was designed. This type of calcium carbonate has some physical characteristics, so its size, but also it was coated. And the last examples, which I like very much, relates to recycling. So you might know that, well, here the issue was the impossibility to mix certain type of plastics, in particular the polypropylene and the polyethylene that makes a lot of the refuse in the plastic, the bottles and so on. It's very difficult to sort at home, and basically we end up with an enormous amount of this plastic which cannot be used. Here, the idea was to find a filler in between so that it would compatibilize the two types of plastics, and this was achieved. So a filler was designed which allows to remelt these two types of plastics together and create a new type of polymer which is usable directly by the industry. An enormous environmental benefit and effect here has been created. Again, that's a special mineral that was designed specifically for that to be used in the plastics. So, just a few conclusions, and I've been invited to look at some policy recommendation. I think what I've tried to do in this presentation is to give you a real case and concrete industry development. We are quite far from these very general ideas and brilliant ideas of policy, industrial and research policy. It's very much down to the earth here. I also wanted to illustrate how our industry and the manufacturing industry is actually fighting on a daily basis, on a constant basis, to try to maintain and to safeguard its competitiveness. All what we have seen here is a mean for the product to be better, to be more competitive on the market, to be more performant. That's what we are talking about, and that's what we are doing. Contrary to this picture, I don't know if you can read it, it recommends not to look back, you are going the other way. I would suggest we need to look back. It's of course very important to look forward, but in our case, and when we speak about industry, it's also very important to look in your rear and not to forget the existing industry. Of course, the 4.0 industry is very nice, but without the real industry, this is not going to exist, and in the meantime, our economic tissue would have disappeared. I have to say in that respect that, well, as an industry representative and in association, we feel quite a significant fatigue of the regulatory burden that our industry is faced with. I would say it's very insidious. That's not it's not visible in the big Eurostat figures. You don't see thousands of companies leaving Europe. That's not like this. It's just that one after the other, the life is getting more and more complicated for our industry. If you combine that with the fact that the growth today clearly is not in Europe, it just adds to tempting the industry when they have the possibility to make the investment and to look outside rather than to look inside Europe. The answer to that is probably more in the last evil than in the big titles. You can think about very small things which in the first place are very nice, like the chemical legislation. We have cases where some of our products are today, well, titanium dioxide, crystalline silica are threatened of carcinogenic classification. If it happens, it has a dramatic effect. We speak about burden on the carcinogen worker protections. Again, there is nothing bad with that, but the premise that the accumulation is loading and loading the boat up to a point where our industry and the using industry will just have all good reasons to try to find other place to operate than in Europe. So I think the answer is, of course, not to suppress legislation. We need legislation, and this legislation are there for good reasons. But please, we need to think together. We need to work together to apply good sense, reason, and reasoned proportionality. Otherwise, I'm afraid the erosion of the manufacturing and of the industry in general in Europe will continue. Thank you very much.
Didier, many thanks. Can you stay there for a second? I have one direct question. I very much liked your very concrete examples. Also a lot about environmental protection, environmental improvement. Is there something where you have new value chains? You mentioned that you have very specific system of supply. But would you have new suppliers, or are you reaching out to new value chains?
My feeling is that today, well, even though the last example I gave you, with the plastics, for instance, is a kind of real new approach, new value chain to a certain extent. This kind of polymer today does not exist, and clearly it's a new kind of raw material. So you can see that to a certain extent as a new value chain. But in most of the other cases, I would say it's rather an intensification and deepening of the relationship in the value chain. Even in our sector, we used to work more in silos in the past. My perception, and certainly the kind of political view of our organization, is to reinforce that when we see these kind of examples, they happen and they have value only if there is dialogue within these different value chains. And as you understood, we are really at the core of most of the value chain in Europe, so we have enormous possibilities to develop these kind of things.
Great. Is there a direct question to Didier at this point? Or we can go on to the next person. Yes, please.
Didier, how long does it take for an idea to come to the market to replace one material by another?
Well, of course, I'm not. You understand that things that. Honestly, it was already quite delicate to get from the companies, so I'm not in the all details of the companies, but my estimation, we speak about things of the order of 3-5 years. That's the kind of thing I would estimate for most of the example I've demonstrated. Maybe a bit less, maybe a bit more in some case, but that's the order of magnitude. So very topical ideas, things which are close to the business, that the business needs. There is, the need is identified. There is a real opportunity from a business point of view that cannot last for 10 years because in the meantime, most likely the demand will have changed, the business will not be there, the people in the companies will be different, and so on and so forth. So the speed of these kind of things for me is of essence to their success.
Yes, please. I repeat so that everyone can hear. The question is about whether behind the examples, what are the investment figures, the employment figures, whether you could go into that.
Honestly, I don't have anything very concrete to tell you. The only thing I can say is that the people at the origin of these ideas are very few people. So we are not huge industry. In general, our companies are mid-size, some multinational size for some of them, but in general, when we speak about the research unit, we speak about a handful number of people who are working with their partners in the using industry. As far as the market are concerned and the employment, honestly, I have no view on exact. But clearly they are, otherwise they won't do it. And maybe one important aspect in that respect as well, and it's a generality for the industrial minerals, is that there is an enormous multiplying effect in what we are doing. As such, our industry is not that huge. We represent a few companies, and in terms of turnover, it's not bad, but compared to other sector, it's quite negligible. The fact is that paper industry depends on us, plastic industry depends on us, and there you have huge multiplying effect in the small things that we are doing. And also, when we look at the competitiveness of our product, I tend to believe that one of the strengths and maybe of the survival condition for our industry is the quality of the product that we are putting on the market. Why are we still quite okay in some sector is because we are ahead of the others as far as the quality of the product is concerned. That's where we are fighting and battling in order to maintain and hopefully to improve this situation regarding the rest of the world with the quality of the product, which can then be used and travel and be used by other people who might produce other part at a cheaper rate and things like this.
Thank you very much, Didier. I think it's time that we give the floor to Susanne. She works for a high-tech company in the Eindhoven region, which is also known for its creativity and dynamics. So the floor is yours.
Thank you. First of all, is this on? Okay, sorry. First of all, I would like to thank the organization for giving me this opportunity to, no, it's not on, right? Is this better? Yeah, it's better. Okay, thank you. So first of all, I would like to thank the organization for giving us the opportunity to present our technology. And most of all, Hans Hartman Pedersen for endorsing us for this conference. So I am from Ionica Technologies, and we are a spin-off company from the Technical University Eindhoven. And there we developed a technology to close the loop for plastics. Plastics are everywhere. In modern economy, without plastics is unthinkable. You have it in food packaging, carpets, automotive, everywhere. You also have it in your clothing. There's much more in clothing even. So the global demand of plastics is growing each year. It was a modest 50 million tons in 1964, but it is expected to grow to more than 1,000 million tons in 2050. So that means that we are also creating more and more waste. And the Ellen MacArthur Foundation estimates that in 2050 there will be even more plastic than fish in the sea. So it's the huge plastic soup that we talk about nowadays. Plastics in Europe in 2014 we produced about 60 million tons. But we only recovered 26 million tons. So that means that 33 million tons is actually lost. And of those 26 million tons, we only recycled 7.5 million in a valuable way. So that's only 13% of plastics, which is reused in a valuable way. So there's a huge challenge there. We created a technology to recycle polyethylene terephthalate. We use PET for food packaging, but we use polyester for clothing. And a quarter of all plastics, plastic waste in the world is actually made from PET or polyester. So there's a huge opportunity for us. Everyone knows the PET bottle, but the PET fiber market is even twice as large. So you can see the PET bottles everywhere. You can see the PET clothing, the polyester clothing, again, everywhere. But it's not just bottles, food packaging, and clothing. It's also there's a huge market also in carpets and automotive, and so on. So at the present day, we still have a linear economy. We make from oil. We make raw materials. We can create PET from that, and then it goes to a large brand who makes PET bottles and so on, and it goes to the consumer. And if you're lucky, it's collected in the right way, so that you can recycle it. However, 90% is actually not collected in the right way, and it goes to landfill or incineration for energy recovery. Or it will be dumped in the nature, and that is something we really should prevent. Recycling is possible, however, this is still mechanical recycling. So there's a huge disadvantage for that, because it can only be like for like. So that means that you can only recycle blue bottles with blue bottles and green with green. Because if you mix them, you end up with an ugly brown bottle. Also, it's a finite method, because you can only recycle a bottle 6 times. If you recycled even more mechanically, then it's not then the quality of your bottle is too low, and you cannot put your water in it anymore. So, with every cycle, the quality of the PET becomes less and less. So that means that you can only do the downcycling. You can go from a PET bottle to textile, but not the other way around. Also, there are limited volumes available. This is because for recycling, you really need PET to be pure. Or you cannot have, for example, the polypropylene or polyethylene mixed with it, because then you also decrease the quality of PET. Therefore, we developed a new technology. It's a circular solution. So what we do is we have our PET waste, and we chemically recycle it into monomers. these monomers are chemically equal to monomers made from oil. So that means that you can create a virgin PET from PET waste. The benefits of our process is that because we make equal monomers as those from oil, it matches with the existing PET polymerization plants. So that means that the PET polymerization plants do not have to adapt their current process. There needs to be, there's a minor investment, but you can directly implement our monomers with the oil-based monomers. We also know that people will not pay any more for recycled contents than they already do for the virgin materials. So that means that we developed a process which is actually cost competitive. Also, the quality is similar, because no one wants to buy a bottle from a light brown bottle. Also, this is 2016 already, so we do not want to introduce a technology which is highly toxic. So we use only non-toxic materials, and our solvents can all be recycled. This makes our process cheap, but also it creates a 75% less CO2 emission. So now we come to the process itself. What do we actually do? We mix any type of PET. It can be carpets, it can be textiles, anything as long as it's PET. It can be very colored, so textiles are high in colorant concentration. We add our solvent and our catalyst, which we call the magnetic fluid. We boil it a bit, we stir a bit, and then we let it cool down again. After the reaction, we can magnetically capture our catalyst, the magnetic fluid. And the beauty of this process is that we can regain our catalyst, but also we create a surface to which colorants or other additives will attach to. So in that way, we can remove colorants and additives in the catalyst separation. And then we come to step 4, and in step 4 we have our high quality raw materials. So, and this high, raw material is equal to the oil-based monomers. Let's go into the magnetic fluid that we use. It has many advantages. First of all, we would like to have a very fast reaction, and that is why we chose the magnetic fluid. We have a high yield because otherwise our process wouldn't be profitable. Also, the magnetic fluid is PET specific. So that means that if you have contaminants like polypropylene, polyethylene, or aluminum foil, for example, which is very common in PET feedstocks, it remains unaffected after the reaction. So it only affects the PET polymer. Also, as I said before, there is easy recovery of the magnetic fluid particles because we make use of their magnetic properties. And finally, capturing of the colorants and other types of additives. Industry called this actually the game-changing feature. The fact that we can deliver a colorless product is something the industry really wants. Of course, we need huge amounts of this magnetic fluid because we have big ambitions, and therefore we are also upscaling our magnetic fluid particles. And luckily, we are involved in the Horizon 2020 co-pilot program, which was also presented yesterday. And here we we co-develop a pilot plant for nanoparticle preparation. Our current focus is a 1,000-liter scale demo plant. This is the actual plant. And it looks quite industrial, and it's quite industrial. It's still a bit dirty, but it's also much fun because now we can actually prove our process to the world. We can show it. We also invite many future industrial partners to join us. This pilot plant is open for industrial partners to test your own feedstock. So if you have a bottle or a textile or possibly a PET chair, you can join us and see whether we can make your PET waste into new clean materials. Our planning is quite ambitious. In 2017, we plan to have a 10 kiloton recycling plant in the Netherlands. And in 2018, we will license this technology globally. And finally, some recommendations for policymakers. Basically, we are nanoparticle producers, but also we are recyclers. And what we encounter is many smart materials. So, for example, multi-layer bottles or textiles with high contents of flame retardants. And that is a challenge for us. For mechanical recyclers, this is a huge challenge. However, for us, it makes our life also a bit difficult. We can handle it, but large contents are difficult. So that's why I would also promote design for recycling. So not just think about how are we going to produce a new product with recycled contents, but also think about how are we going to recycle it? How can we disassemble this product? Also, something we encounter is that we got much subsidies and support for our pilot plant, for research pilot plant. However, now we really want to upscale up to the industrial scale. And that is maybe, again, the valley of death. We still need money, so possibly maybe it's also possible to provide loans for companies like us, so that we can actually go to industrial scale without getting real subsidies from the European Union. And with that, I would like to thank you for your attention.
Many thanks, Susanna. I really enjoyed your presentation. In politics, we have a saying that you can turn eggs into an omelette, but not an omelette into eggs. You showed that you can put back a bottle into PETs.
Yes.
So that's quite amazing. And if we had a prize here at the conference for the nicest iconographic presentation, I think I would propose you as a winner. So is there any immediate question to Susanna? Yes, please.
Congratulations for developing this very nice technology. My question just would be, I mean, chemical recycling of polyesters already exists on very large scale. For example, Aquafil, I think they do it even in Slovakia, or Domo in Germany, they have a 100,000 ton plant. So how do the economics compare your process with the existing caprolactam recycling?
We do have our eyes on competitors. However, we hear from industry that still either the quality of the monomers is not really up to scale, or it's not profitable enough just yet. So what we prove is that we can actually go from the lowest grade PET waste back to bottles, and that's the biggest challenge. And apparently those other companies are still not up to that level.
So it's the purity of
it's
the
mainly,
material.
yeah, it's the purity, yeah.
Thank you.
Thank you very much. Thank you, Susanna. I think we have to move on for time reasons, but we have time for questions later. And remember, you can always use Slido as well. So let me give the floor to Paul. Paul, I'm sure we will hear something from you which relates to the last point of Didier about regulation and proportionality and perhaps the innovation principle.
So thank you very much for the introduction. I'm going to try and see if we can't find something that relates to everybody, but I probably will fail, so apologies in advance. First of all, my name's Paul Leonard. I work for BASF, and I'm responsible for innovation and technology policy. But quite frankly, you could hear this presentation from a number of people, particularly the organizations with whom I work very closely, the European Risk Forum, which is a think tank in Brussels, Business Europe, which represents the industry across the 28 member states, and the European Roundtable of Industrialists. So here's a slide you can't read, and it's there on purpose because it's actually meant to signify the fact that innovation as a subject means many things to many people. And I don't want to pretend that there's only one definition, but the one I'd like you to keep in mind today is commercialization of invention. And that's the most succinct way I know of actually summarizing what the challenge is, what the opportunity is, and also what the problem is. And Didier referred to the regulatory burden, and I'd like to come back to that. What is getting in the way, and what is our intrinsic possibility in terms of this commercialization of invention? The first point I'd like to make is that when it comes to innovation and technology, it's a business of uncertainty. Technological innovation requires taking risks of many sorts. It can be financial, it can be scientific. It's not a point of certainty, otherwise it wouldn't be innovation. And what's important is to understand those risks and mitigate them. We can't have technological innovation without actually understanding and managing those risks. We can't have technological innovation and use innovation to stimulate reindustrialization if we don't accept that concept. And if we try and avoid the temptation to banish risk. Now, the good news was that President Jean-Claude Juncker tuned into this in his very first speech to the European Parliament back in 2014. And he said that jobs, growth and investment will only return to Europe if we create the right regulatory environment and promote a climate of entrepreneurship and job creation. We must not stifle innovation and competitiveness with too prescriptive and too detailed regulations. And I think actually that neatly summarizes a number of comments that our presenters have already made. Now, as industry people in this area, we were very pleased to hear that. And actually this launched something called better regulation, which we're very enthusiastic to hear about as well. And at that time, the European Risk Forum, which was, as I say, is a small think tank, launched the innovation principle. And that's a very, very simple thing. It says that whenever legislation is under consideration, the impact on innovation should be taken into account and addressed in the policy and legislative process. This is designed to bring about a change of mindset. It's relatively obvious to regulate when you see risks. That's the regulator's job. That's what we as citizens expect our regulators to do. But what we're really saying is that Europe is a world leader in that respect, but what we also need to do is protect our ability as European industries, as European entrepreneurs to innovate. And we need to do both, not one or the other. Now, this was launched and supported by a letter written to President Juncker and signed by a lot of signatures you can't see on the right-hand side, but I'll see if I can help you. These are the CEOs of 22 companies from a wide range of sectors, including aerospace, agricultural machinery, IT, consulting, biotechnology, pharmaceuticals. You can read them yourself. It was a cross-sectorial signed letter by CEOs who together employ 1.5 million people and spend 30 billion euros a year on innovation. Now, this was designed to ring a chord, to make sure it wasn't ignored. It was actually a plea for help by the innovative industries. And it was meant to summarize three things, that this is an important call for a change of mindset. It's a cross-sectorial one. It's not related to any one company or any one sector, because it's a systematic issue that we need to deal with, because Europe is remarkably good at research. We're not remarkably good when compared with other parts of the world of bringing those discoveries to market and what we define as innovation, commercialization of invention. That's the bit that we're struggling. For some reason, We're not as good as other parts of the world. Now, we all know about the past. We know about green biotechnology, for example, an innovation that was invented here in Europe that has by and large been pushed to other parts of the world. But the key question is, what about the future? Will Europe, will our policies, will our regulatory systems embrace new technologies like driverless transport? Here we are in Slovakia, the flying car, nanotechnology, the new enabling technologies, the minerals that we heard about from Didier. Are we going to actually put so much burden on that we're not going to be able to embrace these technologies, or are we going to have a mindset that actively goes out and protects our ability to bring these things to market and to use that in order to reindustrialize our society? Now, the point about the relationship between regulation and innovation is that it's a complex one. I'm certainly not standing here saying we don't need regulation. Far from it. We need regulation. In some areas, we need more regulation. I spoke to a colleague recently who's responsible for soil conditioners, improving soils. And he said, oh, you know, we need regulation because there isn't a level playing field. We need more regulation. However, beyond a certain point, it gets in the way. And I'll give you an example. The German chemical industry did a survey of its members and found that 35% of the profitability of the industry is spent on compliance. 55% of the cost of 55% of the profitability of the crop protection industry in Germany is spent on compliance. These are huge costs, and you can call them burdens. And the question is, are they on balance necessary? Could it be done more efficiently? And we have a belief and a faith in the better regulation process to make sure that that balance is right. And I just show you this very interesting extract from a book by Sir Jonathan Porritt. It's called The World We Made. He wrote a book from the perspective of an environmental campaigner from the year 2050, looking back on all the wonderful things that had happened to mean that we had solved our food security, climate change, energy issues, and we were living on a planet in a sustainable way. It's a very interesting book by the Forum for the Future, which he founded. And actually went through that book and highlighted every paragraph which depended on innovation. And the motto of the story is that actually it's not a question of precaution or innovation. It's not a question of sustainability or innovation. And we need both. We need innovation to enable us to live on this planet more efficiently and have less impact on the environment and be more sustainable. We won't solve our future problems by looking backwards. We have to look forwards. And from that point of view, and a number of you might be familiar with it, the precautionary principle is a very, very important part of our treaty. It actually puts the burden of proof on the inventor, and it gives the policymaker a basis for making judgments, even if the evidence is not clear that harm can be caused. Now, this is in the Lisbon Treaty, it's in the Rio Declaration, it's very important, and it would be completely wrong to think that somehow the innovation principle was opposed to the precautionary principle. We believe the two fit together very well. We need to take precautions, and we also need to make sure that we protect our ability to innovate, and in that way we can make progress. The two are complementary, not conflicting. Now, this process gathered momentum. In January this year, the Dutch presidency hosted a very important event on innovation, and here you can see Carlos Moedas, Commissioner for Innovation, and he gave a very good speech there, talking to Marcus Bauer, who's the Director General of Business Europe. Here is Vice President Katainen, and here is an audience absolutely riveted by the idea of the innovation principle. At the top, you see here that Business Europe and the European Roundtable of Industrialists working together. And that's just meant to show that this is not an individual person or company or sector. This is European industry saying we need to do something to bring about a change of mindset. Now, fortunately, we're not the only ones now. The European Council, in its May conclusions, provided a mandate to the member states and to the Commission to see how the innovation principle could actually be used. The European Political Strategy Centre of the European Commission wrote a very nice paper on innovation as a political and legal principle, and basically demonstrated that it's not incompatible with existing legislation, that the various elements are there. We were very pleased to see this because we believe that we're not asking for new legislation, we're asking for the important pieces that are there, like the innovation toolbox in the impact assessment of the better regulation that Prime Minister that was proposed earlier this year. These elements are there. We just need to bring them together in a meaningful package that is intuitively easy to understand. The European Parliament, in the form of a report on sustainable agriculture by Anthea McIntyre, supported the innovation principle, both in the Agriculture Committee and in plenary. The Parliament's Research Service wrote a very good article actually on innovation and included an interpretation and a summary of the innovation principle. And at that point, we were all feeling very happy because all three institutions are now actively talking about the innovation principle. We were looking forward to President Juncker's State of the Union speech, but sadly, the word innovation didn't appear. And I think we have to recognize that our policy makers have many other things on their minds at the moment. In terms of the State of the Union, I think it's our jobs to collectively make sure that innovation is not forgotten, that it is there, it is a priority, because it is what will reindustrialize this part of the world. Now, just to keep you up to date, Commissioner Hogan, Commissioner for Agriculture, made a very nice statement 2 weeks ago in his address to the World Food Day conference. He said the political momentum is there for us to do even more at political level in Europe. There is a growing support for the establishment of an innovation principle to encourage new legislation to be supportive of innovation. I encourage you to take this excellent opportunity and to drive things on. And that's exactly why I came here today. I hope each one of you will do this. This is a process of everybody talking about it. Talk to your colleagues, talk to your friends. We want something here in the legislation, in the interpretation of the legislation, that is actually going to put innovation at the forefront of people's minds as they go through the legislative process. Not just impact assessment, but looking at priorities, plans, evaluating whether or not it's good to legislate. This is when we want to have a knee-jerk reaction from all three institutions saying, is that a good thing for innovation or not? And take that into consideration. It's not saying innovate come what may. Innovation is not necessarily a good thing, but we do want policymakers to think about it on a routine basis at each stage of that process. So, I leave you with my last slide. Thank you very much for your attention, and I hope between us we can move this one forward, and thank you to our other panel members who each one of them have identified the need to do so.
Many thanks, Paul. I'm impressed by the balance in your presentation. I could subscribe to every single one. I'm very glad also you mentioned this article from Paul Kallis, the professor who wrote this paper for our policy think tank, for Juncker, saying that it's actually, as you underlined, it's not in contrast with the precautionary principle. And I think if we look ahead, the future we build, and the best way to predict the future is to build it, it shows how this goes hand in hand. So anyone, I think it's impossible, but anyone who would like to challenge Paul? Yeah, it's almost impossible. We come to that later. But I think it was a strong plea also for all us to get engaged in the innovation principle.
Maybe I could challenge myself for a second, because it's not without challenge. There are those who are very skeptical. The industry all, for example, the unions are very worried that the innovation costs jobs. And I think we have to recognize that there is a legitimate fear there, that if you bring in new innovations, it ultimately costs jobs, and that's something we need to address. And this simply won't succeed if we can't work on it in a holistic fashion, together with unions, together with environmental NGOs, together with society, and especially with academia. And this initiative came from industry. It's now been embraced by the institutions, or is in the process of being discussed by the institutions. I think our job now is to be critical and also to include those who might be threatened by this, and particularly those who feel that it's a threat to the precautionary principle. I read about that, we're challenged with it, and it's simply not what we want to achieve.
Yeah.
Thank you.
Paul, please still stay there, because I have an excellent question on Slido regarding you. And the question is it credible to have some controlled regulation derogation when innovation is concerned? And this is the question of the right to challenge. So can you give us an answer to that?
Okay, well look, I'm not a regulator, but what I would say is an innovative company. A derogation can be very helpful in terms of maintaining an essential technology on today's market, but no innovator is going to invest in the hope of getting a derogation. So, I mean, for me, a regulation that's built on the promise or the thought of a derogation, and for those of you who are not in the regulatory world, you know, this is okay, if you fail the test and you're banned, we might allow you to stay on if, and then there are a whole sequence of decisions that have to be made. This is simply not the way that industry or anybody else, SMEs or startups, will want to invest their futures. It's a necessary step, but I would say where you have derogations, probably have another look at it and say, is this really going to encourage innovation? And is the actual legislation itself needing attention, rather than sticking plasters over it and saying we can make it work? That would be my response.
Very clear. Thanks a lot. Before we move to Anne, I want to, with the thanks to the colleagues who are so excellent in helping us in visualizing the presentation and now also the question, can we have a quick vote here on the question which is about plastic waste? And the question is, do you think the EU is doing enough to decrease plastic waste? Those who think the EU is not doing enough, please raise your hands now. Oh, that can't be. Okay. Those who think the EU is doing enough? Okay, so I think we have a critical mass here. The answer is the EU needs to do more. And there's also another question on this. Maybe we come to this later. Thanks a lot. Paul, Anne, the floor is yours. Technology breakthroughs.
Thank you, Peter. I think that quite a lot has been already said between innovation and reindustrialization, so I can go quick. Yes. So first of all, what I would like to do to establish the link between innovation and reindustrialization is to give you two examples, two case studies that are really very different. The need to decouple growth and industrialization from resources needs to get a transition period, and I would like to illustrate via two examples taken from circular economy and responsible innovation. What we know is that thanks to sustainable development, we can indeed answer the societal needs, but also the stakeholders' expectation. And I think it's really all about what we have already discussed right now. So as was said, the innovation is not only about invention. There are a lot of other ways to make innovation. The thing is that it is about the deployment of this invention, whether it is in R&D or whether it is about business model, for example. In the, just to complete the figure about setting the scene, what I would like to say also is that Horizon 2020 is a huge investment in R&D, which means that here we are more in a specialization strategy. And it is all about increasing the size of the pie, rather keeping it constant. So for me, This specialization strategy means that we are targeting mainly breakthrough innovation. I don't say that we are not targeting incremental innovation, which is absolutely needed, but in this case, we are more in favor of breakthrough innovation. And this has consequences on the way this breakthrough innovation can target and reach the market. 2 years ago, there was a study made by a high-level group on innovation policy management. The secretary was Stefan Scheppers, and part of his conclusion were about innovation acceptance and communication of benefit by industry. And for me, this is key, and this is the two study case that I will present to you. There were some two others disadvantages that were mentioned, namely around the gaps between the various levels, between Europe and member states, and also between government and industry. The two case studies that I want to illustrate are how to develop and how to deploy innovation in nanotechnologies that are key enable. They are no more emerging technologies, they are more key enabling technologies. And I want to illustrate that just by giving the risk, illustrating the risk about ill-defined policies and the problem of the uncertainty in the regulatory environment. And the second one is just a word on valorization of CO2, and this is the second case study. What I would like to start with is about nanotechnology and what is named responsible innovation. So I will come back to responsible innovation a little bit later on. What are the consequences of what you can, well, hopefully read on the screen? So researcher and research organization should remain accountable for the social, environmental, and human health impact of their nanoscience and nanotechnology. Can you imagine? Let's make a trip back 15 years ago. For example, the smartphone doesn't exist at that time. You are a researcher in nanotechnology, you would like to promote something, smartphones are full of nanotechnology. Now, let's hear to some studies that are now emphasizing the impact and the addiction of people to their smartphone, and there are studies that are now released about the problem that some children meet because their parents are always connected to their smartphone. As a researcher 15 years ago, would you feel comfortable to have such kind of consequences? Can you just imagine that such kind of consequences will emerge? That's just not possible. It is about risk that we have already tackled that. So this type of policy is just but good. It's ill-defined. It's not possible, and it is completely inefficient because it does not protect the citizens against problems with nanotechnologies, and it does not help the industry. So it's a very good example of ill-defined policy. And I want, because innovation is also shaking a little bit mainstream thinking, I want just to make a comparison. We are engineers, we are scientists, we are trying to make our best to solve societal challenges with new products. We would be accounting for the consequences of that, whereas let's take the comparison with other type of jobs like economic experts. How many times did you hear at the radio why they were wrong and explaining why they were wrong, but making prediction that everyone think about it's true and that is just released to be not wrong, not true? And in our case, or if you have heard about Galaxy 7, well, it's felt like a shame that the industry does not deliver a product that is completely reliable, why is it a shame in the case of a product, and why is it not a shame in the case of an economical prediction? I am just challenging that. I don't understand why. So, well, that's for the point of, shaking a little bit mainstream. Then the problem of the regulatory uncertainty. So we have this recommendation about nanotechnologies, recommendation of definition of nanomaterial. Europe had the leadership until 2010, 2011. And after that, I don't know what occurred, but it has lost its leadership, which means that now we have a proliferation of national decrees. And so if we want to be active there, we have to monitor, I don't know how many different types of regulation, sometimes starting from 100 grams. Can you imagine? You are in your lab, you are producing 100 grams, you have no idea at all about your product. Yes, you have vague ideas about what will be the properties of your product. You even try to imagine what could be the market behind, and you have already to fulfill a REACH dossier or something like that. It's, again, completely inefficient, and it doesn't achieve the target that is to promote new market to solve societal challenges. Okay, I am done with it. So, how to avoid that? How to avoid ill-defined policies, preventing innovation to be deployed, while answering the expectation of the civil society. This is what we are talking about. And so one way to do that, and this is what we have tried to do since the beginning in Solvay, is responsible innovation as a possible answer. Now, again, I will say, European Commission came with a definition, or not a definition, but guidelines for what responsible innovation means. I have not everything in mind, but it doesn't matter. Here, what we are doing as industrial researcher, because ERMA is the European Industrial Research Management Association, I am representing Solvay there, we are trying to build a portfolio of study case. And in our case, for Solvay, responsible innovation means that we have integrated the innovation process within our sustainable development strategy. Because of, we have put in our strategy that we want to be a sustainable leader, a leader in sustainable chemistry. So this means that in this case, we have elaborated a referential that we name Solvay Way that is matching the expectation of the stakeholders, and among the stakeholders, we have the civil society, we have the environment. And in order to measure if all our innovation, and not only innovation, our business activity, our portfolio of product is matching this referential, then we have developed a tool which is the Sustainability Portfolio Management, SPM, and we are really trying to integrate that into all our processes. So that's our answer to take into account the expectation of the society while developing new product. We have therefore worked with other people, and at the ERMA level, we have tried to set up, as I said, a portfolio of cases in order to provide a qualified industrial contribution to the debate. So again, what you have to know is that in this debate about responsible innovation, these are mainly academics. I have nothing against academics, but innovation is the job of the industry, not of the academics. Of course, we need to have social science scientists. Of course, we need to work with them. But in no case, they are the expert about innovation. We, industry, are the experts in innovation because we make the scale-up, we make the deployment and the commercialization. So that's it for nanotechnology. Any other, I will go beyond my time. I wanted just to mention the second case, which is the Low Carbon Partnership Initiative on carbon capture and usage. It's not yet officially launched. It will be launched in 2 weeks at the COP22. And so it's an initiative that was sponsored by the World Business Council on Sustainable Development last year for the COP21. And the idea is that key industrial players from 3 energy-intensive industrial sectors, meaning chemistry, cement, and steel, have started to work together. And we want to explore together what type of synergy, and when I am talking about synergy, I am talking about processes synergy, product synergy, and not financial synergy. I want to, so the idea is really to understand if we can identify synergy among our process to develop something together that would allow to make carbon capture and use it efficient and a business case. We want to bring facts and data in the public debate, and we want also to identify challenges and barriers for the deployment. This would allow to an industrial symbiosis and a new type of economy, and namely the circular economy. The point is that in this case, what you need is to put different industries together. So first, you have to build trust, you have to find a common vocabulary, and that takes a lot of time. And so, in my conclusion, what I want to emphasize is that for me, as we have Horizon 2020, and as Europe is also defending in this agenda its own value, so reindustrialization is based on breakthrough innovation, but in a framework of sustainable development. And so the 2 case studies that I have given to you were really to illustrate the challenges that industry is facing in 2 very different problems. Innovation acceptance being not the minor one, the least one. And so the lessons that we have up to now is that the first thing that we need is to establish the dialogue with all the stakeholders, which means that we have to establish a trust and a common vocabulary. But for that, we also need to be aware that is a huge problem of segmentation. Segmentation not only between government and industry, but also in the industry itself, between research and top management, between, in the European Commission, between the various directorates. And I think that one of our biggest problems is this segmentation, but also the fact that now what has become the critical success factor is the speed. And we are in a context where we have the difficulty that we have to address this segmentation with 28 countries or 27 countries, while in China or in Korea they have one language, they have what I will say is a kind of a state capitalism, they are far more authoritarian. And so this is a very big challenge, and we need to address that. So I've got it.
Thank you very much, Anne. Now we finally have it, the controversial debate. We need to talk. The ill-defined policy you described so convincingly, I'm personally responsible for it and behind it.
Which I did not know.
So let me give you let me use 30 seconds to try to prove the counter-argument that it's not ill-conceived. What we wanted to achieve is that we do not repeat the mistakes we have done with asbestos, We run into, naively, had a huge problem, still paying for it. And what has happened with the genetically modified organisms. And I'm very proud what happened with nanotechnology. I don't mind that my kids, or that I'm the effects of nano in the mobile phones. But we do have no major incident with nanotechnology and nano safety. We have strong international cooperation on nano safety regulation, and I think it's also partly due to the cooperation, and this is, I agree with your conclusion, the cooperation and the involvement of society, which is the biggest part of what we understand under responsible research and innovation. So we have to talk at the latest over coffee.
With pleasure.
Is there an immediate question to Anne from the floor? Not the case. We have nice questions here on Slido. And I would ask perhaps the panel, because we are already beyond time, to pick one of the questions and have a very short answer, and a closing statement in the second round. So one very quick round. I stop you after 1 minute. Pick a question you want to answer, and then a closing statement. Who would like to start? Didier?
Is it? Yeah. I think I'll take the first one, between the carrot and the sticks, and the position of the regulation in that respect. I would object to that. I don't think we need carrot. In fact, the things which are working, and I refer to your presentation on the polymers, what works is then when there is an economic case for something, then it works. Each time the regulation tries to impose something, it's just blocking the industry, it's blocking the development, and at the end of the day, it's not sustainable. So we need to get in a position where the regulation is following the trend and what the society wants and what the industry is able to deliver, rather than to try to constantly impose something. And maybe there it links with the balance between precautionary and innovation principle. It's nice in theory. In practice, the precautionary principle is always over the other one. Or taking it over the innovation one. So it's nice in principle, but in practice, no one will take the responsibility, and it will be precautionary. That's what we have seen in all the files we can mention.
Thanks. Suzanne?
I will also go into the first question, because are there effective penalties to make waste costly? I think there are none. In the Netherlands, I know that for consumers, they are implementing reverse collection. So instead of all the waste, the municipal waste which is mixed, now they're picking up the plastic waste, which people actually need to sort themselves. So in that way, it's not really a penalty, but it's more of a reward that they collect. But I do think that governments and the European Commission should make people more aware that people should sort their own waste. Educate people that it's important, and educate people that there are problems when you don't sort your waste properly. It is not just the recycling, but also the environmental impact.
I think I'll follow the first question as well. The theme about a carrot and a stick, I'm not sure that's a really fair way of positioning it, but you know, we need precaution. We need to make sure, and you can call it a stick if you like. I think there's an expectation on policymakers to protect us as human beings, to protect the environment, and that's completely clear. But if we're not careful, this cost of compliance is taking away investment that would otherwise be available for innovation. It's a defensive R&D. Each company, each industry has a certain amount it can invest in innovation. The more of that we spend on complying with legislation, the less there is available for innovation, and the less there is available to compete as innovators with the rest of the world. That balance has to be right. If it goes beyond a certain point, technologies will simply leave this part of the world because those who are investing can choose to put it somewhere else. If it goes below a certain point, you can then argue that perhaps the level of attention to protection isn't high enough. I think it's a very difficult job, but I think there are cases where certainly as the industrial sector, we're saying the balance is going too far in one direction and we really need to refocus on protecting our ability to innovate.
Anne?
I will take the second one because there had been already three, which is a difficult one. You may see that also like a kind of portfolio management of the industry in Europe. And so trying to have, after having the inventory and knowing, well, what are the strengths, build on those strengths for sure. But in order to go to new high-tech, it has to be in a balanced way, I will say, if I see it from a portfolio management. So where put I my investment, on which are the bets that I am doing? Which means that in some case it can be lower risk, in some case it can be higher risk. For the high risk, what we know is that the uncertainty is really high, and that's exactly the problem with the emerging technology, because as speed has become the critical success factor, once they appear in the laboratory, they almost immediately reach the society. That's the problem. And this is why we need to have a kind of online regulation. You see, it's by essence, up to now, regulation was lagging by essence because the cycles were slower. So this means that there were some time for the regulator to adapt, to understand. This is no more the case. So we have to really work hand in hand with all the stakeholders, as I said. But the point here is really to understand where do you take risk and how much, and high or low risk.
Thank you, very clear. So we are already a bit late and there is delicious coffee and these fantastically delicious sweet strudels waiting for us before the next session at 11. But I would like each of you to give us one wish for the EU, for the industry, one wish, what you take out from this discussion. Very, very brief. So, Twitter links. Paul, you're the first.
Thanks.
Welcome.
I wish that we would keep in our mind the risk of saying no and the risk of not doing something.
Very clear. Who's next? Susanna.
I wish Europe would take again the leadership on the industrial world.
Shared.
I wish that small companies, really innovative technologies, really get an opportunity also from the European Union to make it to the world, because it's still hard for companies like us.
Didier, last word for you.
Yeah. I wish Europe not only to look at breakthrough new technology, but also to build on the resilience of its existing economic tissue.
Great. Thank you ever so much. Thanks to our panel. I think they deserve a very warm applause from all of you and all of us. Thank you. I really enjoyed it. Thanks a lot. Thanks a lot. We have to talk.